Warm greetings to everyone. We are B3D Toys India Private Limited, a startup company from National Institute of Technology, Tiruchirappalli, India. We are mainly into building Edu-tech toys to help children to learn STEM concept in simple and fun-filled ways. The company details is displayed in this screen for your reference. Our ultimate objective is to develop toys which will keep the children engaged with physical models that helps them to develop hand-eye coordination, spatial awareness, cognitive quotient, problem-solving ability, team building skills, etc. We are determined to develop indigenous Edu-tech toys which helps the children in 5 to 18-year age group to learn mathematics, science and arts in an easy and better manner. In connection to this, we are happy to introduce a new product called the Nodal art toys,
which in our opinion will improvise the conventional teaching learning pedagogy.
The key idea of our product is to use eco-friendly and readily available materials, for instance, pencils, juice straws, etc. as connectors along with the 3D printed nodes to create interesting and educative STEM models.
Now, we'll see the advantages of our product and its comparison to other products. A product is indigenously developed at a rapid prototype facility at the Department of Energy and Environment, NIT Trichy. We have used eco-friendly material for connectors and biocompostable material called polylactic acid for nodes, and it's easy to recycle.
A sequential algorithm is developed for each distinct geometry so that children can assimilate all important aspects related to geometry of their respective curriculum. A product is cost effective with respect to the volume occupied by similar products. For instance, the cost of a product occupying a volume of 39,304 cm3 is around 300 rupees, whereas for Lego it costs around 2000 rupees, which is almost 6 times as higher cost as compared to our product. A product can be easily scaled simply by changing the length of the connectors, which is not possible with similar product available in the market. Other value additions like integrating electronic components to produce light and sound effects to our product can be done. Now, we'll see about nodes and connectors. Nodes and connectors are building blocks of our nodal art toys using which the desired STEM model can be made. A node is a 3D printed object of any shape which contains a set of nodal points. Each nodal point is basically a vertex of a 3D STEM model, whereas connectors is an edge or a line formed by joining two nodes, or in other words, two nodal points. Design of nodes. In our project, nodes are designed as spheres which have 13 nodal points at which holes are generated. These points are designed in such a way that each point have a unique nodal number from n1 to n13 assigned to them. So by connecting the connectors in the respective nodal points, we can be able to generate our desired 3D structure. A separate algorithm is provided for complex 2D and 3D shapes like polygons, prisms, pyramids and platonic solids. Design of connectors. We can use various things as connectors, namely straws, bamboo sticks, wooden sticks, pencils, etc. However, in this video we are using pencils as connectors.
A set of nodes and connectors intended to build a specific group of toys is called as a module. For example, automobile module, geometry module, wild animals module, etc.
The first module we have developed to exhibit the uniqueness of our product is Module 1, the geometry. This module is developed for children of the age group 5 to 10 years. The intention of this Edu-tech toy module is to teach basic geometry from primitive things like points, lines and polygons to complex 3D geometries like dodecahedron, icosahedrons, etc. by using make and learn approach. In geometric modules, spherical nodes with 13 points are generated. Each nodal point is given a unique identification number which is printed near each nodal point. This module requires 20 nodes and 30 connectors. Now, we will see the demonstration of this geometric module. Okay, these are called nodes. These are called connectors. So this is basically nodal art toys. So let's start with points. Point is defined as a location in a space. For example, this is a point. So this point is at a distance of say 1 meter from this point. So this is also a point. So these are points. So infinite number of points when joined together make a line. So when all these points join together, this makes a line. So and this line is extended to infinity. So then comes line segment. So when we join two points together and join together, we get a line segment. This has a starting point and an ending point, and this is called as a line segment. And now, if we remove one of the start or one of the ending point, and it has only if it has only a starting point, it's called a ray, where this points to infinity. So these are called points, lines, line segments, and rays. So we are going to talk about angles. So what is an angle? When two lines join together, we form an angle. So when these two lines join together, we form an angle. So the angle formed between these two lines is called an acute angle. And now, if we furthermore rotate this line, we get a right angle. The angle formed between these two lines is called an right angle. If we furthermore extend this to here, we get an obtuse angle. And furthermore get extended, we get a straight line which is 180 degree. The two angles are said to be adjacent angles when they share the common vertex and the side. The endpoint of the rays forming the sides of an angle is called as the vertex of an angle. Adjacent angles can either be complementary or supplementary when they share the common vertex and the side. When the sum of measures of two angles is 90 degree, then the angles are called as complementary angles. When two angles are complementary, each angle is said to be the complement of the other angle. When the sum of measures of two angles is 180 degree, the angles are called as supplementary angles. When two angles are supplementary, each angle is said to be the supplement of the other. Now, what happens when two or more lines join together? It forms a polygon. So first polygon is triangle. This is when three lines join together. It forms a triangle. So we'll try making a triangle. Now, an interesting property about triangle is that when we sum up all the angles, it's equal to 180 degree, which we will see in this video. Whoa, we got ourselves a triangle. Now, it makes me wonder what will happen when four lines join together. We get a quadrilateral. Now, a magic snap. Now, this quadrilateral is called as a square as all sides are equal. We'll learn more about triangles. First type is when all the three sides are equal. This is called as an equilateral triangle. Move on to the second type. When two of the edges make 90 degree with each other and then forms a triangle, it is called a right angle triangle. Now, if any two sides of the three sides are equal, then it's called an isosceles triangle. Now, in the equilateral triangle, all the angles are equal to 60 degree, but in isosceles triangle, the angles opposite to the equal sides are equal. Moving on to four-sided polygons. Now we are going to start off with square. When all the four sides of a quadrilateral are equal, it forms a square, and then it has 90 degree. Now in rectangle, when opposite sides are equal, it forms a rectangle. In rectangle also, all the angles are 90 degree. We are now seeing some other quadrilaterals such as rhombus, parallelogram, trapezium, kite, pentagon, which can be made using our nodes and connectors. Module 2. The second module we have developed is about complex 3D structures like platonic solids, prisms, and pyramids.
Platonic solid module is an extension of the geometric module, as the same sets of nodes and connectors are used here.
In this module, we'll learn about what is platonic solids, why are we using platonic solids, and what are prisms and pyramids. Also, we'll see the demonstrations of the above mentioned structures. What are platonic solids? A platonic solid is a 3D shape where each face is same as a regular polygon and has the same number of faces meeting at each vertex. There are 5 types of platonic solids: tetrahedron, cube or hexahedron, octahedron, dodecahedron, and icosahedron. Why are we using platonic solids? Platonic solids are symmetric structures where one half of the structure is the mirror image of the other. In platonic solids, all edges are equal in length. So because of these reasons, we'll be using platonic solids and also try making other 3D structures using the same set of nodes and connectors in this video. Pyramid. A pyramid is a polyhedron for which the base is a polygon and all the lateral sides are triangles. Now we'll see the making of some pyramids using our nodes and connectors. Prism. A prism is a three-dimensional solid object in which two ends are identical. It is the combination of flat faces, identical bases, and equal cross-sections. Now, we'll see the making of some prisms using our nodes and connectors. Module 3. The third module we have developed is about automobiles. In this module, we'll see the demonstration of automobile as 3D structures like cars, pickup trucks, etc. We are developing more modules for kids, namely wild animal modules, etc. If you are interested in purchasing any of it, please contact us. The contact details will be displayed in this video for your reference.